Hello guys, this is Ishan Akbar. In this video lecture, uh, basically this is the part 2 of the dimensional analysis. In the last part of the video, we discussed Relay's method for dimensional analysis and deriving a relationship between dependent and independent variables. In this video, I would teach that how can we derive a relationship between dependent and independent variables by using the second method, which is known as the Buckingham Pi method. Because I told earlier that there are two methods for dimensional analysis. The first one is the Rayleigh's method, and the second one is Buckingham's method. So we have discussed previously in the last lecture the Rayleigh's method, but in this video I would be discussing about Buckingham's Pi method. Both of them are used to derive a relationship between dependent and independent variables, but their functionality is somewhat different. So I will elaborate the difference between two uh, in a short duration so that we can understand the difference between Rayleigh's and Buckingham Pi method. In Rayleigh's method, we directly deal with the variables, that we show the dependence of a dependent variable on multiple independent variables. Let us say that y is a dependent variable whose value depends upon x1, x2, and x3. And then we consider or we form a function phi which operates on values of x1 raised to power a, x2 raised to power b, and x3 raised to power c. Then we find a relation between these variables like this one, and we induce a constant k which will convert their relation to a product, x2 raised to power b and x2 raised to power 3, c. So this is the process to derive a relationship between dependent and independent variables using Rayleigh's method, where we deal with the variables directly. But in case of Buckingham Pi theorem, as its name suggests that this is a pi method, we basically form the pi groups. So this method also operates on the variables, but it operates on variables indirectly. Basically, here the groups of variables are formed in which there is no distinction between the dependent and independent variable. They are all considered in pi groups. As we saw in the Rayleigh's method, that independent variables remain single and other dependent variable remains single, and its value depends upon the values of independent variables x1, x2, and x3, and they are on the other side of the equation. But in case of Buckingham's pi theorem, we put all the functions, all the dependent variables y, x1, x2, and x3 in the same function and operates it like it is equal to 0. So this is the functional form of the Buckingham's pi method applied on four variables, in which one is dependent and the other three are independent variables. So, moving towards the introduction of the Buckingham Pi method, this was deduced by E. Buckingham in 1915. This is the more generalized method as compared to Rayleigh's method, as it can be applied to any number of variables. And here, basically, we form the pi groups. How many pi groups can be formed? It depends upon the number of variables, number of total variables. Those variables may be dependent and independent. We will form a group of dependent and independent variables if we see that we have four variables. Y is dependent, x1 is independent, x through x3, x4, and up to so on. Let us say we have n number of variables and these are to be related using Buckingham Pi method. Then we will count that there are total number of variables is are n. Sorry. And what are the number of dimensions which we have as basic dimensions? Those are basically three, because those are known as m, l, and t: mass, length, and time. So these basic dimensions are subtracted from total available number of variables. Let us say in the equation we have limited number of variables. Let us say 5, x4, 3, 2, 1, and y. So we have 5 total number of variables in this equation, in this relation, and basic equations are 3. Then we will form uh, two pi groups. So basically, Buckingham Pi theorem is applied to a condition where n minus n is greater than 0. So we can simply say that n minus m must be greater than 0 for Buckingham Pi method to be applied, because we basically need pi groups. If n is equal to 3 and m is also equal to 3, it will be 0, so there will be no pi group. Then we will move towards the relays method. To apply the Buckingham Pi theorem, we have written here that not applicable if n minus m is equal to 0. To apply Buckingham Pi method, you must get the answer of n minus m equal to 1 or greater than 1. It will be automatically in whole numbers. So if total number of variables are n and equations our basic dimensions are 3, so we can say that n minus m will be the available number of pi groups. So the next thing, the first step is number of pi groups. How many pi groups we will form to find the relation between the variables. And the next thing is repeating variables, that how repeating variables are selected. This is a very, very important step in Buckingham Pi method. So the first condition to select a repeating variable is that it shouldn't be dependent variable. So in repeating variables, dependent variable should not be included. It can never be included in the repeating variables case. The second is they must have all the dimensions. So what does this mean? This is a very vast statement, so you need to understand in a simple example. It does not mean that we have to include all the variables which must have m, l, and t dimensions. No, this means that if you are taking three variables as repeating variables, so you must uh, have m, l, and t in all three variables. Mean if we are selecting a velocity as a repeating variable, its dimension is L by T. There is no M in this. So we will include another variable in this in this group as density. This is M L minus 3. It means that in if these variables are repeating variables, they are okay because M is included in this density and L and T are included in V. Here is no T. T is missing here, M is missing here, but here T is available, and in this value or in this variable M is available. So all of the repeating variables must have at least M, L, and T in them. So the statement written here, the point written here is selecting repeating variables, they must have all the m fundamental dimensions, mean they must have three dimensions. There should be at least one time m, one time l, and one time t in all the repeating variables. If all of the repeating variables contain at least once m, l, and t, then they can be selected as repeating variables. And the third condition for selecting the repeating variables is they should not be from same property. Same property mean all of them can never be geometric variables. Mean geometric properties. If you are taking the diameter of a pipe as a repeating variable, so you cannot take the radius of the pipe as a repeating variable. You can take only one property from one group. Mean we have three types of properties. If we are considering a channel, flowing channel, so we can open channel or close conduit or anything. So you can take the geometric property as a repeating variable, you can take the material property as a repeating variable, and you can take the flow property. Mean we can have three repeating variables in this case, that diameter of the pipe is one repeating variable, roughness of the pipe is the or roughness of the channel is the second repeating variable, and velocity of the flow is the other repeating variable. So we can get three repeating variables in this case. Why? So how will we decide that how many of the variables will be repeating variables? This will be cleared by the number of pi groups. I will let you know in the example that how can we get the number of repeating variables, how many of them must be repeating. So diameter has nothing to do with the roughness, and roughness has nothing to do with the velocity, and velocity has nothing to do with the d and n. Mean any one of the variables should not influence the other variables. So basically, in most of the cases, we will have three repeating variables because basic number of dimensions are three. And you have again to be careful that all of the repeating variables must have m, l, and t dimensions in them. If the whole group does not contain all the dimensions m, l, and t, so they cannot be considered as the repeating variables. You have to include at least one parameter, one repeating variables, which will complete the set of the dimensions. Mean m, l, and t should be there. So I have included an example that there is a sphere that is moving through any fluid. Let us say we have this pipe and fluid is moving in this pipe, and a sphere like 3D sphere is moving in this fluid in this direction. And if anything moves in a fluid, a drag force acts on this substance or this material or this sphere. So the amount of the drag force, Fd, is a function of is sphere through a fluid may be affected. Mean this drag force is affected by sphere diameter d, velocity of the sphere v, density, and viscosity. So what will be the relationship of these variables? So how many variables we have? We have to count the total number of variables, including the dependent variable, unlike Rayleigh's method. So total number of variables: 1 dependent variable, 2 independent, 3 independent, 4, and 5. So total number of available variables is 5. So how many basic dimension do we have? These are basic two questions. How many basic dimensions do we have? So mostly, in most of the cases, this will be 3 because M, L, and T are mostly available in the questions. So how many? The third important questions. And these three are the back-to-back questions. If these are missed, you cannot go with the Buckingham Pi method. How many pi groups? So pi groups will be, this is called n and this is called m. So n minus m is equal to 5 minus 3 is equal to 2. So this is the basic question which we want to know to move with to carry on the Buckingham's Pi method or Buckingham's Pi theorem for the dimensional analysis. So if you get the answer of this value exactly, then the problem will become very easy for you. So simply, what will we do? We will form two pi groups. How can we form two pi groups? Keep in mind that I will move first with the functional form. Functional form is phi including the dependent variable and all the independent variables equal to 0. Mean phi is a function which will operate at a time on dependent and independent variables, and the answer will be equal to 0. From this group of 5 variables, we will form two pi groups. So first pi group and the second pi group. We have to include all these 5 variables. So basically, you have to consider this point very seriously and with a lot of concentration, that total number of variables are 5 and total number of pi groups are 2. So what is the answer? This is 2. Total number of variables minus total number of pi groups. This is 3. So this is the number of repeating variables. How many variables can be repeating in this case? These are 3. In most of the questions, the repeating variables will be 3. mean equal to m, but in every case you have to deduce the number of repeating variables. And again, the second condition, dependent variable, mean in our case dependent is fd. Dependent variable can never be repeating variable. So you have not to include the repeating variable, or you have not to include the dependent variable as a repeating variable. So in our case, it is clear that the pi 1 group will be comprising of three repeating variables and one non-repeating variable. So our first step is to check the repeating variables. We will need three repeating variables. So what, fd can never be a repeating variable. So erase this. We have diameter, this is the geometric property. We have velocity, this is the kinematic property. And we have rho, density of the material. This is basically the material property. You can include the rho because this is the material property, and this kinematic viscosity is also the material property. So we cannot keep this rho and mu as repeating variables because these both are the properties of the material. So we have to include at least one, like this: d, v, and rho. This can be repeating variable, but in all the pi groups, the same three will be repeating variable. We cannot change the repeating variable group in different pi groups. If in first pi group you are taking d, v, and rho as the repeating variable, and in the same second group you will take all of them as the repeating variables. So in each group there will be one non-repeating variable. In first group, because we are not including fd as a repeating variable, so it will be the first non-repeating variable, and in second place this will be the mu. Mu and rho can be in one group, but repeating variables cannot be in a single group. Mean you cannot form a group. Let us say we are going to form a pi 3 and this will be comprising only of these three variables. This cannot happen. It means repeating variables can never form a single group, a single pi group. So repeating variables must be constant in all the pi groups. If we have 10 pi groups, then all the pi groups must have same repeating variables. You cannot change the uh, group of repeating variables in first pi and second pi and third pi. It will remain constant. You will just change the uh, non-repeating variables. So if let us say you say that I want to induce this mu dynamic viscosity as the repeating variable, so you have to erase this rho. Here in this case, you will replace this one mu, and here it will be replaced by density. You can go in this way. This depends upon that what you want to do in the case. So moving towards the solution, pi 1, this is a function of pi 1 is a function of how many variables? D, V, rho, and FD. And pi 2, we'll solve this one first. Pi is a dimensionless number. If you say pi is 22 by 7 and this is a constant value, say it has no dimensions. We can see that m has zero power in left hand side, L has zero power, and T has zero power, mean constant value has no dimensions on the left hand side. So this is basically another difference between the Buckingham Pi and Rayleigh's method, because in Rayleigh's method on left hand side there were some dimensions. There were m raised to power 1 or t raised to power something or L raised to power something. But in this case, in every pi group, there will be no power on any of the dimensions. M, L, and T will be powerless, mean their power will be zero. And what will we do? We will simply induce the powers on repeating variables, mean d raised to power a1 into v raised to power B1 and rho raised to power C1. We will induce powers on the repeating variables, but non-repeating variable will remain as it is. And in the next phase, we will simply put the dimensions on the repeating in the place of repeating variables. So what are the dimensions of the repeating variables? D is the diameter. This is L raised to power A1. What is V? Length over time raised to power B1, and rho is M L raised to power 3. This will be C1, and FD is force. Kg ms minus 2 is the unit of this one. This will be ML, M raised to L power nothing. So this will remain same. So because force is equal to M into A, M is the mass, and this is LT minus 2. So this will be ML to T raised to power 2. So M and L are multiplied with each other. And repeating variable will have no power at all in all the pi groups. So to solve this equation, we have to convert them in product. So to convert them into product, we'll simply write m raised to power 0, l raised to power t raised to power 0, and we will induce a constant for pi group, first pi group, that is k1, and it will be l raised to power a1 into L raised to power b1, t raised to power minus b1, because t will be shifted on in the numerator and its power will be negative. And in the same case, m will be c1 and L raised to power minus 3 c1, and again m L t raised to power minus 2. This is a relationship in the form of a product. So on the left hand side, m raised is 0, L 0, t raised to power 0, k1 into L. What are the powers of L? They are solved simultaneously. Here the power of L is 1, so it will be L raised to power a1 plus b1 minus 3c1 plus 1. What are the powers of m? M is has a power of only 1, and here is plus c1. This is 1 and this is c1. And t is, here it is minus b1 and here it is minus 2. So simply we will compare the powers on left hand side and right hand side. M is 0 on left hand side, so for m we will form a equation 0 equal to our power of m is 1 plus c1. And for L on left hand side, you can write 0 with closed eyes. So L here is a1 plus b1 minus 3c1, a1 plus b1 minus 3c1 plus 1, and for t we have 0 on the left side, and here is minus b1 minus 2. So from this equation we can get the value of c1 as minus 1. We can get the value of b2 if shifted to this side. This will be plus b1. B1 is equal to minus 2, because minus 2 will remain here. And if value of c1 and b1 is adjusted here, we will get the value of a1. So a1 basically will remain on this side. This plus 1 will be shifted to other side. This will be minus 1. This plus b1 is shifted to other side. This is minus b1. This minus 3c1 is shifted to other side, plus 3c1. Now put the values of constants b1 and c1. Minus 1 minus b1 is minus 2, plus 3 into c1 is minus 1, is equal to minus 1 minus minus plus, minus 1 plus 2 minus 3 minus 4 plus 2, it will be minus 2 here. So a1 is equal to minus 2. So we have three unknown exponents a1, b1 and c1, and we have got them. We will move towards the first thing, our first relation, that pi1 is equal to, here you can say that this is pi1. So pi1 is equal to d raised to power a1. What is d's power? It is a1, so it is minus 2. What is v's power? It's b1, and b1 is equal to minus 2. And what is rho's power? C1, that is equal to minus 1. And now we have fd as a repeating variable, a non-repeating variable. So pi1 is equal to fd. There is a relationship between these variables. All inverse powers will be shifted to downward, d square, v square, and rho. So this is basically a relationship of fd and other repeating variables in first pi group. And in case of second pi group, what will be the relationship? In second pi group, we have a non-repeating variable as d, v, and rho, and this is the dynamic viscosity or simple viscosity. So we'll say that pi2 is equal to, in the same case we solve the pi1, we will again solve the pi2. For these dimensions will remain same, but powers will be converted to a2, b2, and c2. For each pi group, will some just change the subscripts for the a, b, and c, and they will become a2, a3, b2, and c2. And for third pi group, if there is any third pi group, that will be a3, b3, and c3. For fourth, a4, 5, b4, and c4. For nth pi group, it will be an, bn, and cn with one non-repeating variable. So what is the dimension of dynamic viscosity? This is m over lt. So simply we'll put the dimensions of, we will put the powers, d raised to power a2, v raised to power b2, and rho raised to power c2 into mu. And now put the dimensions m0, l0, t0 for pi, and k2, and we have to put the dimensions for m. This is l raised to power a2. This is v, l t inverse, lt minus 1 raised to power b2. I'm directly writing. And rho is m l raised to power minus 3 to c2 into mu is m l inverse t inverse. And now solving, I will go directly because I elaborated everything in the first pi. So by comparing the powers of m, 0 on the left hand side, and where is m? Here is m, this is power c2, and here the power of m is 1 plus 1. So simply c2 will be equal to minus 1. Again same as in the first case. And for l, on the left hand side the power of l is 0. On the right hand side it is a2. Here it is plus b2, and here is minus 3c2, and here it is minus 1. So at the end of the solution, there will be some difference. I will show you. Some of you may think that because the repeating variables are same, so why we are going to compare the dimensions? So basically, non-repeating variable will influence the answer, final answer, because the dimensions of repeating variables here are m l inverse t inverse, and in the last case, they were m l t square. So you can see here, in case of L, comparison of L here was plus 1, and in now pi group this is minus 1. So answer will change. And for comparing T, T is 0 here, and on the right side this is minus B2, and here it is minus 1. So from this B2 is equal to minus 1. And what will be A2 here? A2 will be equal to this minus 1 will become plus 1 on the other side, minus B2 plus 3C2. So we'll put the value of B2 and C2. 1 minus B2 is minus 1, and minus plus 3 into C2 is minus 1. So it will be 1 plus 1 minus 3. It will be equal to minus 1. So value of A2 is equal to minus 1. So here we got the values of exponents A2, B2 and C2. We'll put their values here. Pi 2 is equal to d raised to power A2 is minus 1. V raised to power minus 2 and rho raised to power minus 2, and mu will remain same. So basically here we can say that the relation becomes mu divided by d v square mu square. So we have two pi groups and the function operates on pi 1 and pi 2 up to so on and gives an answer of 0. See here. Here at the bottom of the page. At last we will form an equation in this form, that a phi function will operate on different pi groups and will give an answer of 0. This will be the final relation. So phi will be operating on two pi groups in this case and will return an answer of 0. So phi will operate on fd divided by this relation, d square v square over rho, d square v square into rho. And what is the pi 2 second pi group? This is mu over dv square rho square. This will be mu over dv square rho square is equal to 0. So this is the final relationship which is formed between these fundamental parameters, these five variables, fd, mu, and dv and rho. You can see here the in denominator the variables are same. Mean there will be three variables which will be repeating in all the pi groups, and there will be one variable which will be once in the each pi group. In first pi 1 we have fd as a non-repeating variable, and then second pi group we have mu or dynamic viscosity as the non-repeating variables. So I hope that this discussion will make you able to understand the basics of Buckingham's Pi theorem. And in the last video, we discussed the relays method. Still, if you have any questions, we can discuss. You can send me a mail. You can send me a message. We can discuss. You can comment in the comment section to discuss any ambiguity in this topic. See you in the next video. Take care. Thank you very much. Allah Hafiz.